Okay, guys, good morning. Welcome back. Today we are going to start Chapter 8. We're going to be talking about adding and subtracting polynomials, okay? And before I even start the lecture, I do have to say, this is now getting into a new part of algebra. From polynomials, we're going to go into some heavier mathematics. We're going to go into factoring trinomials, which is then going to lead to solving trinomials, which is then going to lead to quadratic equations and functions, which will lead to solving quadratic equations and functions, which will lead to rational equations, which will lead to radical functions. So we have an awesome road ahead of us, but it is going to take some time and it is going to take a lot of effort on your parts. If you guys do not learn the basics, starting with today, but like really learn them awesomely, you're going to suffer in this chapter. Also, the power rules. We didn't learn them just to learn them. We are going to be using power rules from now on the whole rest of the year. So I know you can do this. I believe in you, but practice. Don't get lazy, because the beginning parts are really, really, really simple. But it's the small details that people forget that hurt you later on, okay? So, before we start learning about polynomials, let's investigate both terms and like terms. We've already talked about these two items before, but let's go ahead and revisit them. A term is any real number, okay? Any real number, variable, or product of any real numbers and one or more variables with whole number exponents. That is the key here. Remember that. Whole number exponents, okay? They can't have fractional exponents. They can't have negative exponents. They have to have a variable, a number, or a product of real numbers and variables. Examples of terms: 5. 5 is a term because it's a number. 3x squared y cubed. That's a term because that is a product of numbers and variables. And the exponents are whole numbers. The exponents of x are 2 and the exponent of y is 3. 2x. That is a term. That is a term because it is the product of a number and a variable. 4xw. That is a term because it is the product of a number 4 and two variables x and w, and they have whole number exponents. If you don't see the exponents, remember those are invisible, guys. Okay? All right. Now, let's talk about like terms. Before I even define like terms, if I were to go to the store, okay, I'm with my mom and we're doing some grocery shopping, and she says, "Son, go get the apples." So I go and I get 5 apples. All right? And then she comes back with pears. And she has 5 pears. Do we have 10 apples? No. Good job. Do we have 10 pears? No. Why? I have 10 fruit. Why can't I call them apples? Different. Thank you. They're different fruit. They're different variables. Good connection, son. Like terms, kind of like the apples and the pear example, you cannot add or subtract any terms unless they are like terms. And in order to be like terms, they have to have the same variable raised to the same power. Same variable raised to the same power. All real numbers are like terms, by the way. Any number, 5, 9, negative 15, 12.8, 16.7, 3/5, 2 halves, or 2 halves is 1, 2/3, 5/7. All of those are real numbers. All numbers can be added. Numbers are always like terms. And only like terms can be added or subtracted. You cannot add 5x plus 3y. That just equals 5x's plus 3y's. You can't combine them because they're not like terms. So let's look at some examples of like terms. 2x and 3x, they're like terms. You can add them together, by the way. What would 2x's plus 3x's equal? Just out of curiosity. And what would 2x's minus 3x equal? Negative x. Remember, guys, 2x minus 3x, when the signs are opposite, you subtract as normal, keep the sign of the largest absolute value. Remember, that's something we learned in chapter 1, and some of us are still struggling with that. That is the only reason is because of lack of practice. Please be careful with that, my friends. Okay, another example. 5x squared y cubed and 3x squared y cubed. Those are like terms. What's 5x squared y cubes plus 3x squared y cubes? 8x squared y cubes. We do not at all affect the variables here. You're just affecting the coefficients. You're adding the coefficients, guys. You're adding the numbers in front of the variables. Think of these here as a type of fruit. That's like 5 apples, or look, I did a shape, even better. 5 triangles plus 3 more triangles, because they're both the same. Has to be 8 triangles, right? Where the triangles are x squared y cubed. Does that make sense, guys? Just like when I buy 5 apples and then 3 more apples. I don't have 7 apples squared, do I? No. When do I add the exponents, just out of curiosity? When I multiply the same base. Very, very, very good. So just for giggles, what if I had 5x squared y cubed, bless you, times 3x squared y cubed? What would that equal, gentlemen? 15 x to the 4th, y to the 6th. When you multiply the same base, you add the exponents. Good job, well done. That's the kind of stuff we're going to need to really be able to refer to back and forth whenever we want, okay, guys? Does that make sense so far? Cool. All right. Now that we have an understanding of what terms in general are, now we can dive into polynomials, which are created from terms, guys. Polynomials come from terms. The first and most basic kind of polynomial, okay? Because a polynomial is basically one term or the sum of one or more terms. That's all a polynomial is. So the first most basic type of polynomial is called a monomial. Think of mono, the root mono in Latin is for one, singular. Okay? Monomial. Mono, one. So a monomial is going to be any real number, variable, or product of any real number and or one or more variables with whole number exponents. Basically, a monomial equals a term. Did you catch that? A term is a monomial. Any real number, variable, or product of any real numbers and one or more variables with whole number exponents. That's an example of a monomial. That's a term. Okay? Now, what are some monomials? 6. That's a number. It's a monomial. Negative 4y squared. That's a number, and that's a variable, and the variable has a whole number exponent. So that's a monomial. X, that's a monomial. It's a variable. And the exponent is 1. That's a whole number exponent. We're good. We're golden. W over 3. That's a real number. That's 1/3. 1/3 times W is W over 3. W has a whole number exponent. That's a monomial. 2.5 xy cubed. 2.5, that's a number. That's a real number. X is a variable. Y is a variable. And the exponents of x and y are both whole numbers. So those are examples of monomials. Now, sometimes you got to see what a contradiction is to really understand this. So examples of non-monomials now. These are not monomials. These are not monomials. 8 over x. This is not a monomial, and I'll tell you why. 8 over x, can't that equal also 8 to the negative 1? Is that a positive whole number? No, that's an integer. That's negative, right? That's not a whole number at all. That's an integer. So this is not a monomial. So what does that tell you? Anytime you have a variable in the denominator, it's not a polynomial. You may want to write that down. Anytime you have a variable in the denominator, it's not a polynomial. Anytime you have a variable in the denominator with a positive exponent, it is not a polynomial. And I say with a positive exponent because, look, if I have this, guys, 8 over x to the negative 3, doesn't that really equal 8x cubed? So that would be a polynomial. So one more time. Whenever I have a variable with a positive exponent in the denominator, it is not a polynomial. You had a question, sir?
Yeah. What about if the x was like a 2x?
Even if it was a 2x, if it's in the denominator, 8 over 2xy, not a polynomial. Not a polynomial at all. If I have a variable, 1 or 2 or 50 million, if I have a variable with a positive exponent in the denominator, it is not a polynomial. Okay? Does that make sense so far? Okay. Next. X over the square root of y. What's the square root of y? Well, we're going to get to that when we learn about radical functions. But basically, a square root, that means that it's y to the 1/2. Don't worry about y right now. But I'm going to just let you know, give you a hint. Anytime, whether you have a variable in a square root or in a radical, anytime you have a variable inside of a radical, whether it's in the numerator or denominator, if a variable is inside of a radical, it is not a polynomial. Okay, so far we have, if you have a variable in the denominator with a positive exponent, it's not a polynomial. If you have a variable inside of a radical, whether it's in the numerator or denominator, it does not matter. If you have a variable inside of any radical, it is not a polynomial. And last but not least, x to the negative 4. Is that a polynomial? No. Why? Because you have a negative exponent. Very good. So, variable, if you have a variable with a negative exponent, not a polynomial. If you have a variable with a positive exponent in the denominator, not a polynomial. If you have a variable inside of a radical, it could be a square root, a cube root, a fifth root, inside of any radical, it is not a polynomial. Is everyone with me so far? Awesome. Okay, now, the degree of a monomial will lead later into the degree of a polynomial. The degree, though, guys, is the sum of the exponents of its variables. Literally, period, done. It's the sum of the exponents of its variables. The degree of a non-zero constant is 0. And guys, just so you know, a non-zero constant is basically a real number. Any number by itself, it has an exponent of 1, yes. But the degree of any number by itself, the degree is called 0. So why don't we do some practice here? Okay? What is the degree of each monomial? For A, what's the degree here? What's the degree, guys? What's the sum of the variable exponents? 1. Isn't there an invisible 1 here, guys? Okay. What's the degree of 5? 0. So 0 plus 1 is 1. The degree is 1. Read the sum of the exponents of its variables. What is the degree of b?
4.
4, guys. Because there's an invisible exponent here. 1 plus 3 is 4. The degree of 4 is 1, but the degree of any constant is 0. What is the degree of c? 5. Very good. Because it's the sum of the variable exponents. What is the degree of d? 2. Because it is the sum of the variable exponents, which in this case is 1 and 1, but they're invisible. E, what is the degree of this monomial? 5. And f, what is the degree of this monomial? Very good. What is the exponent, though, of 11? 1. But the degree of any constant is 0. Yes, sir. We're not there yet. We're not there yet, so give me 1 second, guys. Now that we understand, okay, we have an understanding of monomials, we can now introduce polynomials. A polynomial is basically a monomial or sum of monomials. For example, 2x plus 3. That is the sum of 2 terms. You have 2x, which is a monomial. You have 3, which is a monomial. And they're being added together. So that's a polynomial. Next, you have negative 8y squared plus 7x minus 3w. That is the sum of 1 term, 2 terms, 3 terms. So basically that is the sum of 3 monomials. That is a polynomial. And for the last example, that's just 1 term. That's the monomial. But guess what? A polynomial, like it was defined, is a monomial or the sum of 1 or more monomials. Now, let's go over the basic kind of polynomials which you should know how to recognize. A monomial is a polynomial with 1 term. A binomial, think of bicycle, 2 tires, 2 terms. A binomial is a 2-term polynomial. A trinomial, tricycle, tripod, triangle, 3-term polynomial. After that, guys, when I have 4 or more terms, after that it's called an nth term polynomial. An nth term polynomial. And that's just a 4 or more term polynomial. So if I have a polynomial with 8 terms, it would be called an 8-term polynomial. Is everyone with me so far? Easy, right? But there's already a lot of different little vocabulary. There's a lot of little restrictions. Easy, but as long as we learn the rules. Okay. Now, polynomials are usually written in standard form. And standard form basically means the polynomial is written from the largest degree to the smallest degree. As always, from left to right. The degree of a polynomial, pay attention, the degree of a polynomial is the degree of the highest degreed monomial within the polynomial. For example, I've got x squared y fourth plus xy cubed minus x to the squared y to the fifth. Guys, what's the degree of this monomial here? What's the degree of this monomial here? What's the degree of this monomial here? What is the degree of the polynomial? It would be a 7th degree polynomial. Again, why, Mr. Morrow? Because the degree of the polynomial is the degree of the highest degreed monomial within the polynomial. Does that make sense, guys? So you have to look at the degree of every single term you're given, find the largest degree, and that is the degree of the whole entire polynomial. Does that make sense, guys? Awesome. Now, let's fill in some blanks, huh? Let's see if we got what we came for here. You don't know the name using the degree, so for this square, I understand I'm going to have to provide the answers. But for everything else, we can figure it out together. Okay? So I'm giving you the polynomial in the first column. Then you can read degree, name using degree, number of terms, name using the terms. Okay, so my polynomial here is 15. What is a degree? Yes. The name of a 0 degree polynomial, guys, is called a constant. It's constant because it doesn't change. You have no x to manipulate it. You have no y to manipulate it. You just have one value forever. A constant would be something like y equals 6. Do you remember the equation y equals 6 where you have like this, here's the 6 and it goes like this forever? Isn't the y value constantly 6 here? Hence, why it's constant. Does that help make that connection, guys? Okay. Thank you, gentlemen. All right. Let's continue. How many terms? What's the name of a one-term polynomial? Monomial. Done. Next, what's the degree of this second polynomial I've given you? 1. Do you guys know by chance, do you remember, because this one you do know. No, it's not constant. Constant is when the degree is 0. Okay? When the degree of x is 1, what kind of an equation do we have? We graphed these already. They're called, come on, y equals mx plus b? That slope, no. Guys, x and y intercept doesn't even make sense. It's linear, guys. When x has a power of 1, it's linear. And with all due respect, y equals mx plus b is called the slope-intercept form. The x and y intercepts are found as follows. X-intercept is the x value when y is 0. Y-intercept is the y value when x is 0. And then you guys also said it's slope. Slope is y2 minus y1 over x2 minus x1. And that is the m of y equals mx plus b. So please, I really hope you go back in time and review this, because the final is coming up soon, and I love to make them challenging. Hey, how many terms? There's only 2 terms here, guys. You have, that's a term, and 4 is a term. Terms are separated by plus or minus signs, so there are only 2 terms. What is the name of a 2-term polynomial? Very good. Okay, next. What's the degree? Wrong. The degree here is 2. There's a 1 for the x. There's a 1 here, so the degree of this is 2. There's a 1 here. The degree of that is 1. That has a degree of 0. Why did you guys say this is a degree of 3 out of curiosity? You added the 1 of the 2, and that's wrong. The degree of any whole number, we just talked about this, is 0. These are the things that are going to get you. Like I said, easy lesson. A lot to digest. So this is 2. The degree is 2. You guys haven't learned this one, but out of curiosity, does anyone know what the degree is when it's squared? It's a U-shaped graph. It's called quadratic. Okay, it's quadratic. How many terms in this example here? 3 terms. This is going to be a trinomial. Very good. Okay, next. What's the degree of the 4th example? 3 is the degree. This one you probably don't know. Whenever x is cubed, it's called a cubic. It's called a cubic. Whenever the degree is 3, that is cubic. How many terms in this bad boy? Okay, someone said 6 terms. How is that possible? there are only 3 terms here. And this would be called a trinomial. Last example. What is the degree of the last example? 4. Not because of this 4, but because of that 4. Okay? Be careful with that. What is the degree here? In this case, you would say a 4th degree. Just like after trinomial, it's n-term polynomial. Same thing for degree. You have a constant when the degree is 0, linear when the degree is 1, quadratic when the degree is 2, cubic when the degree is 3. And if you have 4 or more as a degree, then that would be an nth degree polynomial. In this case, it's a 4th degree. How many terms? What's the name?
Monomial.
Monomial. Very good. Now, when you're given polynomials with degrees higher than 3, which is what I just explained, they are called nth degree polynomials, where n is the degree of the polynomial. When given polynomials with more than 3 terms, they are simply called n-term polynomials, where n equals the number of terms in the polynomial. So for example, 5x to the 6th plus 3x to the 4th minus 2x cubed minus x squared plus 12 would be read as a 6th degree 5-term polynomial, because you have 1, 2, 3, 4, 5 terms. Does that make sense, guys? Because now we're ready to rock and roll. Now I can actually teach today's lesson. All of this was stuff that I needed to show you before you actually really could understand the lesson. Okay? Yes, you had a question? Okay. Okay, now, once you have mastered recognizing polynomials, it is essential that you learn how to add and subtract polynomials, which is very easy. All you have to remember, only like terms can be added or subtracted. Only like terms can be added or subtracted. Okay? So let's do this, guys. Let's add 2x cubed minus 5x squared plus 8x minus 5x cubed plus 7x squared minus 19. The first things first, guys. This little negative outside of parentheses, this should indicate something to you. What does this indicate, guys? You have to distribute it to everything, right? Remember we talked about distributive property a long time ago? So once you distribute it, rewrite it. Make your life easy. So you've got 2x cubed minus 5x squared plus 8x minus 5x cubed minus 7x squared plus 19. Thank you. Now, guys, add and subtract your like terms. What I like to do is, until you get a handle on this, help yourself. 2x cubed and negative 5x cubed. Those are the only like terms with a degree of 3. So that's negative 3x cubed. Very good. I get rid of these. They're done. Negative 5x squared and negative 7x squared. Negative 12x squared. Fantastic. Then I have only my plus 8x. Good. Plus 19. Done. You cannot add any of these anymore because they're not like terms. What is the name of this polynomial by degree and term number? Huh? No, nth term doesn't even make sense. Okay, nth term doesn't make sense. N, huh? Okay, no, it's not an nth term. N is the number of terms. So with all due respect, that is wrong. So how would you name this using degree and term? This is a cubic. No, just cubic. You could go cubic or you could go 3rd degree, but remember, when the degree is 3, isn't it called cubic? So 3rd degree or cubic 4-term polynomial. Guys, for those of you who said it's an nth term, nth is what? N is the number of terms. Telling me nth term doesn't mean anything to me. Because I can have 7 terms or I can have 600 terms. N is the number of terms. So this is a cubic or third degree 4-term polynomial. Does that make sense, gentlemen? Excuse me. Next. Okay. What do I have to do here first, guys? Distribute. Thank you. Distribute to all of this. Distribute to everything inside of there. So I've got x to the 4th minus 5x squared plus 3x. Help me out here. Plus. Yeah. Minus 2x cubed plus 6x squared plus 5x. Awesome. All right. Let's add like terms, guys. What do we got? Okay, wait. What now? You have x to the 4th, and x to the 4th equals 2x to the 4th, guys. Whoever said x to the 8th, I'm sorry, but you need to start relearning chapter 7. X to the 4th times x to the 4th is x to the 8th. But x to the 4th plus an x to the 4th is simply 2x to the 4th. Done. It's like buying an apple and another apple. No. It's going to be minus 2x cubed. Remember what we said, my friends? That when we're writing a polynomial, we write it in what's called standard form. Standard form goes from highest degree to lowest degree. Next. Plus x to the 2nd or x squared plus 8x. Done. And what is this called? It always goes by degree first. So this is a 4th degree 4-term polynomial. My friends, I am going to make you do this on the quiz and tests. So I hope you're writing notes on this. This is a 4th degree 4-term polynomial. Next. Okay, here I'm going to have to add first, and then I'm going to subtract. So let's go ahead and separate these. First, let's do this, and then we'll do this second, okay? So, straight up, we have plus. We don't have to distribute anything. So what do I have here as a sum? 3x squared plus x squared. Come on, guys. 4x squared minus 3x, thank you, because 5x minus 8x is negative 3x. And then negative 12 plus 3 is minus 9. Now, don't I have to distribute this negative to everything? So you have good minus 5x squared minus 11x plus 9. Okay, what do I got then? What's my final answer? Okay, which is it? X squared or negative x squared? It's negative x squared, guys. 4x squared minus 5x squared is negative x squared. Minus 14x, because negative 3x minus 11x, goodbye. And then negative 9 plus 9, 0. What is the name of this polynomial by degree and terms? Quadratic. Very good. I like that. It's a quadratic binomial. Very good. Excellent. Very nicely done, guys. Very nicely done. Okay. Now, sometimes they're going to ask you to apply this, okay? Then I'm just going to tell you straight up, it's like this. In the real world, sometimes we have to use polynomials to get answers. For example, let's say that I want to find the perimeter of this rectangle. What do we know about the sides, the opposite sides of rectangles? They're congruent. So, if that is 2x squared minus 3x plus 14, what would the top be? Okay, so let's go ahead and clone that bad boy. That's right there. Awesome. If the width here, or the height, is x minus 5, the other side will also be x minus 5. Now, now, does anyone remember, we've gone over this before, the formula for the perimeter of a rectangle? Yes, sir. Very good. Perimeter equals 2 times width plus 2 times length, right? Now, we haven't learned how to multiply these yet, correct? However, isn't basically 2w basically this width plus that width? And then 2l, that plus that? Okay, so let's go ahead and find our perimeter here, guys. Let's go like in a circle, okay? Let's go this way, investigating each piece one at a time. So let's first start with my 2x squared. 2x squared, does it link up to anything here? How about to here? What's 2x squared plus 2x squared? 4x squared, done. Goodbye, goodbye. Doesn't link up to anything there. We're back at the beginning. You with me? Okay. Negative 3x. Okay, what's negative 3x plus x? Negative 2x. What's negative 2x minus 3x? And what's negative 5x plus x? Negative 4x, and we come back to the beginning. So that's negative 4x. 14. What's 14 minus 5? 9. And what's 9 plus 14? 23 minus 5. 18, and we come back to the beginning. And guess what, guys? That's my perimeter. Does that make sense? Really, really easy. Sure. Well, there could be a lot of different ways to do it. I'm just trying to make it as easy as possible. I mean, if I were to see this, to be honest with you, I would have just multiplied everything here by 2 and distributed. But we haven't learned how to do it, so it's not fair. Another thing I could have done, I could have just recognized, okay, I got a 2x and a 2x squared, so that's 4x squared. Negative 3x, x, negative 3x, and x. So negative 3 plus 1 is negative 2, negative 5, negative 4. And then, last but not least, I would have just said 14 minus 5 is 9, plus 14 is 23, minus 8 is 18. So there's a couple ways to skin that cat. Does that make sense? Thank you. Oh, yeah. Thank you. Good job. What would you call this by degree and term? Quadratic. Cubic is third term, guys. Quadratic. Quadratic. Trinomial. Very good. Next. Okay. Now here, perimeter of the triangle, perimeter of any shape, basically all the sides added together, right? So what would this perimeter be, guys? You tell me this time. Start with the highest degree, of course. Guys, I didn't ask for the area. I asked for the perimeter. Perimeter is all sides added together. So again, starting with the highest degree term, what do we have? 6x cubed. Very good. 3x cubed plus x cubed plus 2x cubed is 3x cubed. No. Guys, standard form. You have 2x squared because it's 4x minus 2x is 2x squared. Okay. Plus 4x because you have negative 6x, 5x, and 5x. That's 10 minus 6 is 4x. And then 9 minus 2 is 7 plus 6 is 13. Very good. What is the name of this polynomial by degree and term? It's a cubic. It is not a trinomial, guys. Hold on, relax. If it's not a trinomial, how could it be a binomial? It's a cubic fourth term polynomial. My friends, God bless you. Have a great day. Homework is valid. Study. I'm telling you, study. I'm telling you, study. God bless you all. Have a great day.